Example 1. Sketch the graph of y equals 72 plus x minus x squared. First thing to do is to work out the roots, also known as the x-intercepts. And we do that by setting y equal to 0, factorising and solving. 72 plus x minus x squared. Now you'll notice the x squared term is negative, and at the very end we're not going to turn it around, we're going to factorise it as it is. So we want the factors of 72, and it's going to be 9 and 8. 9 times 8 is 72, and from a 9 and an 8 I can also get a 1x. So an x here as well. We want a plus 1x, so I want a plus 9 and a negative 8. Those are the factors. Next line, 9 minus x equals 0. 8 plus x equals 0. This gives me x equals 9. And this gives me x equals minus 8. So I can put those into brackets. 9, 0 and minus 8, 0, like so. Second thing to do, the y-intercept, and that always occurs when x equals 0. So we'll go to the original equation and substitute in 0 for x. And we get the number 72, which is a big number, but it won't be a problem for us. So we've got the point 0, 72. The third thing I want to do is to work out the axis of symmetry, and what I'm going to do is to add the root 1 and root 2 together and divide by 2. So we had x equals 9 and x equals minus 8. I'll add them together, divide by 2, and that gives us a half. So the equation of the axis of symmetry is x equals 1/2. Now, what I want to do then is to find the coordinates of the turning point. We can discuss the turning point, the type of turning point, in just 1 minute, but for the moment, what I want to do is to substitute x equals 1/2 into the original equation. So it was y equals 72 plus x, so that's going to be 1/2, minus x squared, so it's negative 1, I don't want the negative there, negative 1/2 squared. So it's 72 plus 1/2 minus 1/4, half squared is 1/4, that's 72 and 1/4. And that's a big number as well, but we can deal with that. So the turning point then has coordinates 1/2, 72 and 1/4. The last thing I want to do is to sketch. So here are some axes roughly drawn. Label them x and y. You'll notice it's not a big diagram. The last thing I want is a big diagram. I've got we had a root at 9, and it's not drawn to scale either. We had a root at minus 8. Now you remember the original equation, it was y equals 72 plus x minus x squared. It's the minus x squared that tells us that we are dealing with a sad face. So I'm just going to draw that. Now you also remember that we had a line of symmetry at x equals 1/2, which is somewhere just about here. So the turning point has to lie on that line of symmetry. And here is a rough sketch then of what the diagram looks like. We're going to go through the y-axis here and then continue going up just a wee bit and then down like so. Okay, so this is the line x equals 1/2. This here is the point 1/2, 72 and 1/4. As long as you put the information on the diagram like I'm doing, it doesn't matter if it's not drawn to scale. this point here, which is the y-intercept. I hope you can see that. The y-intercept just there. That has the value 72. And you can see it's just below the maximum turning point. That's the other thing I want to say. This is a maximum turning point. Example 2, y equals x squared minus 9. Now this is an interesting one. What we have here in fact is a difference of squares. Here's the first square, here is the sign indicating a difference, and here is the second square here, x squared minus 9. First thing to do is to work out the roots, and they always occur when y equals 0. So x squared minus 9 equals 0, and you may have forgotten what to do with these quadratics. So it's x and x, 3 and 3, one bracket is a positive and one is a negative, it doesn't matter which. And then we can set the first bracket equal to 0 and the second bracket equal to 0 as well, and x equals 3 and minus 3. So the roots are at 3, 0 and minus 3, 0. Second thing, the y-intercept. Y-intercept occurs when x is 0. So if we go to the original equation and sub in x equals 0, we've got 0 squared minus 9, which is minus 9. And the y-intercept then is 0 minus 9. The axis of symmetry. Can be found by adding the two roots together. So we've got 3 plus minus 3 and dividing by 2. Now 3 plus minus 3 is 0. So we've got, lo and behold, an axis of symmetry which has equation x equals 0, and a line which has equation x equals 0 is in fact the y-axis. Now that may seem a bit puzzling, but I'll explain that in just a minute. 4. We want the coordinates of the turning point. What we're going to do then is to substitute x equals 0 into the original equation, but we've already done that. The equation is x squared minus 9, so it's 0 squared, and that might seem puzzling as well. Final thing then is the sketch. So, y-axis, the x-axis. Now, we've got a root at minus 3, and we've got another root at 3. The graph has equation y equals x squared minus 9. Here we have a positive x squared, which means we've got a happy face. So I can actually draw the shape in. Like so. Now, here is the y-intercept here. That's at 0 minus 9. We have an axis of symmetry at x equals 0, which is this line here. I did say it was the y-axis. So I'll just put in x equals 0. And this number here, as well as being the y-intercept, is also the minimum turning point. And that sometimes happens. And its coordinates are 0 minus 9.